This conference will now be recorded.
Okay, welcome back. Good morning. I just now created a Kubernetes cluster through Terraform. So since it's taking first 5 minutes. So yesterday we discussed limit ranges in pod, and then we tested with one pod with extra resources. It was not able to create, and then later we saw environment variables. We resolved this problem with config maps, and then we discussed secrets. Now we will discuss one important thing in secrets, that is image pull secrets. Whenever we pull, whenever we push one image to the private repository, it by default Kubernetes cannot get the image like here. So when Kubernetes is trying to get the image, if it is public, it will directly get it. If it is private, we need to provide some authentication to the Kubernetes, how to pull the secrets. So how to pull the image, that is through the secret actually. Okay, now let us do that. I will create one private pod. Okay, before that I need to create image. Okay, let me create image. Okay, here I will create one private image. Docker file. I created one private repo as well. We can this don't have the public access. Let us push our image to this private repo. Okay, so here from Alma Linux 8, can give any simple thing. Okay, and we have already something. Let us just copy it. Okay, this is private. Okay, first we need to build this. Let me first push it. Docker files. Okay, git add. Okay, commit. Okay, push. Now let me start one Docker instance to build the image. Cron cd docker file cd private docker build -t private repo colon v1 dot. Let us try once again. Okay, file system. Let me remove the old images. Docker rmi -f docker images -a -q. Okay, now I got some space. Let me build it. Okay, now I will do docker logout. If you try to push this, okay, today I created a private repo in another account. Okay, docker images. If you want to push to Docker Hub, you need to give your username /. If it is a private repo, for example, Docker, I need to give tag. When you are pushing your local image to some private repo, you need to provide your URL, repo name, usually username as well, username, repo name, colon, tag. This is how you have to give your format. So now, since it's Docker Hub, you no need to provide the URL by default. I need to provide my username and then repo name tag. Okay. Now I am tagging Docker tag private repo colon v1 with my Docker username / repository name and then tag. That is this one. Okay. Now if you push Docker push, then you need to provide like this. It's getting error because I need to log in. Okay, login succeeded. Now you push it. Now it pushed. So I pushed one image to a private repository. Okay, now I will go here and then I will try to pull through the pod. For example, here I can say private image. Okay, API version v1 kind pod metadata name. I will give it as private pod spec containers name private image. You need to give your full one, Siva KMR469 /private repo colon v1, and then that's it. Let us try to push this pod and see what error it gives. Okay, 8 resources. Before that, I need to get the configuration of Kubernetes. So we have our Minikube running. Okay, I need to get the configuration, right? Configuration will be like cd slash k8 9 scp scp hyphen I trainers, and then CentOS @ configuration is in home directory kubeconfig. Now I want this into .kube/config. I pull the kubeconfig. Now you need to set the path. Export kubeconfig equal to .kube/config. Now kubectl get nodes. Okay, you are able to get it. Now let us push kubectl apply -f and then 07. Okay, I need to go inside the pods 01 pods 07. I'm pushing this. Pod got created. Now let us see kubectl get pods. Okay, you need to give the configuration here. Export kubeconfig equal to okay, you see the error image pull back off. So we saw another error earlier, crash loop backoff. Crash loop backoff is your Kubernetes is able to pull the image, but it is not able to start the container. That is crash loop backoff. Image pull backoff is your Kubernetes is not able to pull the image from the repository. If you see kubectl describe pod private pod, you can see the error backoff pulling image, error image pull backoff. All this is you can see here pull access denied. So this is the error you get when you try to pull a private image. So for that we need to provide image pull secrets. Just type Kubernetes image pull secrets. Here Kubernetes will tell you how to create that secret. Okay. And the secret through the command line you can create a secret like this. Okay. If it is Docker Hub, you no need to provide your server. If it is any other private server like your Nexus, you need to provide that as well. And then Kubernetes create a secret for Docker registry type. And then this is the name of the secret and your username and your password and email. Email can be anything, just some email at gmail.com. Okay. So I'm just stopping the screen for some time to provide the password. Okay. Now I'm running this command to the Kubernetes. Okay, now secret got created. kubectl get secrets. Okay, so the secret got created. Now you just need to provide this secret to the Kubernetes pod. Here the syntax is like under spec. Here, just go and see image pull secrets like this. Okay. Now, while pulling this private repository, Kubernetes will get this secret, authenticate, and then it will create the pod. Now, let me delete the previous one. Sorry, I applied again. And then apply now. Now let us see our pod got created or not. kubectl get pods. Yeah, it's getting created. Okay, now it is running. So that's how we use secret to pull the private images. Okay, let me copy these two secrets. Any doubts? Okay, shall we proceed to the new concept called storage?
Yes, you can proceed.
Okay, now let us discuss storage. This is very important in Kubernetes. We didn't discuss much in we didn't discuss much in the Docker concept. Okay, now let us discuss the storage. For example, you are working on a computer and you open one Word application. While you are writing something in the Word, the memory will go to the RAM until you save it, right? The memory will go to RAM. If you save that, it will go to hard disk. Okay. So now what is the storage preference? For example, when you are writing Word, the memory is going to the RAM. Suddenly your laptop got switched off. Then you will lose it, the entire thing, whatever you have written. So that is called as ephemeral, right? Ephemeral means living for temporarily. Ephemeral meaning, if you say temporarily, temporary. Okay. Living for a very short time. So Docker containers, Kubernetes pods, all these are by default ephemeral. Whenever they are running, whatever the amount of storage, whatever it is processing, everything will be terminated when you kill the pod, when you kill the container. Just like this, your Word application. But if you save it, it will go to your system hard disk. Today you saved it to the hard disk. Tomorrow you open your laptop. If it is crashed, then what will happen to the hard disk? Again, you lost the complete data. So in that case, what we do actually, we do the external storage called external hard disk. Okay, now you store your data to the external hard disk. Whether your laptop crashed or your Word crashed, everything, but data will be still there in external hard disk. You will connect it to the different laptop. Still, you are able to access the files. Okay, this is the general concept. The same concept works 100% same in the Kubernetes as well. Okay. So in Kubernetes, let us go down. This is Kubernetes cluster. Inside there is a node, and inside there is a pod. Okay, pod gets some storage to the Kubernetes. Ultimately, pod gets some storage from the node. Ultimately, the storage is in here. We don't know where exactly it stores. It is some random storage. Whenever your pod is killed, then you will lose this storage. Okay, that is called ephemeral storage. When you delete your pod, when you lose your pod, by default pod will remove this random storage. Okay, and we can have another option. You can create one directory here and attach to the pod. Okay, if you lose your pod, you still have your directory. You can attach to this another pod. So in that case, you don't lose the data. Okay, we saw this already while discussing Docker. If you kill the container, if you remove the container, by default you lose the memory. Containers, where it will store is cd var lib, and then here there will be a Docker directory. Here container will store the data actually. So in this directory somewhere. That is random, we don't know. And last time we discussed one example. We created a data here, something like MySQL data, and then we attach to the pod, we attach to the container. Even you lose your container, your data was still there. Same thing here, you create a directory, you attach to the pod, even you kill the pod, the data will be there. But in a Kubernetes, the concept is like multiple nodes, right? Okay. In Kubernetes, the concept is multiple nodes. It's not a single cluster. If, for example, there is a node 2, we are not sure where the second pod will go. Second pod may go to this one. Okay, second pod may goes to nodes 2. Then in that case, Kubernetes cannot attach it. Kubernetes cannot attach this directory. Okay, because it is in node 1. Clear till this? Any doubts? Okay, if you create the directory in the node, if the pod comes to the same node only, then it can attach. If the pod goes to the different node, it cannot attach. So that is the concept. To solve this problem, what we have is external storage. Same like hard disk, we have external storage. Now instead of attaching this, you attach this to the pod. Okay, your data will be safe here. Even you lose the pod, you lose the node, you lose the entire Kubernetes cluster, you still have your data available in this external storage. Okay, so this is the concept. Anybody who did not understand this, just same like your laptop case.
I'm good, bro.
Okay. So in Kubernetes, we have multiple kinds of storages. One is like empty directory. This is same like the pod. This case random storage. It will create one random storage wherever the pod is running in the same node, that is empty directory. And then we have host path. So you create one directory here and you attach to the pod. That is one thing. And then another thing is external storage. Okay, let me write it in YAML format so that you will better understand the YAML format as well. You know, we can write anything your nodes in an YAML format. For example, we have list of storage options available here, empty directory, and then host path, and then external storage. Now I can come here, I can say disadvantage. When you lose your pod, you lose data. Okay, and here the disadvantage is when the pod is moved to another node, you cannot attach. This is the disadvantage. So these two disadvantages we can resolve in this external storage. Okay, so in this the concept is like storage class, and then persistent volume claim, and then persistent volume. Okay, so these three are very important usually for interviews or practical. Also in your projects also we use these three things. Okay, this is also you should know. Now let us create Kubernetes volumes. Okay, we'll come to this. First I want to discuss empty directory. One empty directory dot yaml. So very simple, it will create one directory. Now you see the syntax. I'm creating a volume. Okay, just I will keep it up under spec. Under spec, I'm creating one volume called cache volume. That is the type is empty directory. Okay, the syntax is like this, just braces. Now I created a volume. Think like I created a volume or you created a folder in your laptop and you need to mount this folder to your Docker container. Okay, volume mounts. Inside the container, you are mounting it to the slash cache directory, and you need to give the same volume name. Okay, here through this syntax you should understand, like, I created a folder called cache volume. I need to attach that to the pod through the mount. Okay, now let us just take CentOS, because Kubernetes containers we can, Google containers we cannot take the shell. CentOS command sleep 1000. Okay, I created a volume. I am attaching it to the container. You create any number of volume. You see it's a list. You create another volume and you you mount that volume to another container. Okay, cd storage kubectl apply -f01 empty directory. Okay, now let me take this into Windows to open a shell. Set kubeconfig equal to kubectl get pods. Okay, now what is our pod name? Test pod. Our test pod is running. Kubectl exec -it test pod bash. Okay, now you see the mounting options. We have slash cache. Okay, now I go to that cache directory and create one hello.txt and then write something hello.txt. Okay, now I told you this is creating a random folder inside your node. Okay, let us go and check that. Minikube ssh-i turkey trainers CentOS sudo su cd var lib kubelet. Here just search find in this directory -name hello.txt. Okay, you see here this is available inside the pods, and there are some random directories created by Kubernetes, and you have it available in, you see in this random directory, and there is volumes, empty directory, cache volume. Here it is available. Okay, now if I just edit something here, okay, I don't have it. If I edit something here like hi, then you can see that inside the container as well. Okay, you can see this here, extra text. Now if I delete the container, let us go back 37A50, right? Now let me delete this pod, kubectl delete pod and then test pod.
Bro, looks like this one is visible.
Your voice is
For
not
me
clear.
only or others?
Your voice is not clear.
Yeah, yeah, now it's visible actually.
Yeah, tell me. Okay, now it got
Um,
deleted. Let us go and
uh,
check.
I have,
You can see there is no such file or directory because the directory also got deleted when you delete the pod. Yeah, tell me, Ravi, you are saying something.
can you open the YML? I have few doubts regarding
Yeah.
this. So here, what is the folder name created in the container and what is the name created in the pod actually?
So you're not creating anything in the container. You are not creating anything in the node also. I just
Okay.
gave the volume, cache volume. Then
Mm-hmm.
Kubernetes is going and then creating here inside. Just we saw right inside a kubelet directory. Somewhere it is going to create this cache volume. That's a random. You don't have control. Okay. You don't know the
The
location
name should be the
also.
default or we can give any name,
No,
bro,
you
instead
can
of
give
cache.
anything. You can give anything, bro. You can give anything.
That name will create, right? Randomly,
Yeah, with that
any
name
location.
it will create a directory inside your node, and then
Okay.
you just use the same name to mount it, because while mounting your pod should know, right? Your container should know whatever
Yes,
name you
yes.
give here. I'm mounting here, under which you can give any name also here. What is the path?
That path should be there in the, I mean, existing, right? The
No
slash
need, no
cache.
need, no need.
Okay.
Okay, it will just
Okay.
create a directory inside cache and it will mount the volume. That's it.
Okay. Inside that cache directory, it will mount the
It will
random
mount
whatever
the
the directories.
this random folder created.
Okay.
Okay, this is
Okay,
just
bro.
like
Okay.
Docker container also, how it does the same.
Okay.
And we go to the next option, that is this one, creating a directory inside your node and mounting it to the pod. Then we will see. Okay, this is host directory, host path, host path.aml. So we will have the example here itself. Host path. Just give CentOS, CentOS command sleep 1000. Okay, now first you need to create the directory. Okay, and then this is directory. You can see directory location on the host, and you are mounting the existing directory in the host to the pod. Okay, now I will just give it as host path. Pod name is host path, and I am giving it inside the container. I am mounting it to the host path. Okay, you can leave it here, host volume, host volume. Before running this, I need to have this directory exist inside the host path. Okay, let me create that directory, mk directory slash, what is the directory name? You can give host data also, host data. Okay, directory got created, and then I'm attaching this volume to the pod. Now let us apply this. Let's go to Kubernetes pods, kubectl get pods. Host path is running, kubectl exec -it host path bash. Okay, now you see here you have /host path. Just go there and then create one file, and you can just go inside your node. It should be available. Okay. Now what I do, I will delete this part. Let us see the data will be deleted or not. kubectl delete. It's deleted. But data is still there. Okay. It's getting terminated. Okay, terminated. But data is there. Now, again, if I apply, let us go and then check the pod can still access the data or not. It should access. cd host path. So you can still access. So what happened here? I created a directory and then I attached to the pod. Now I removed the pod, but data is still there. Again, I created another pod. Still, it can access the data because it is provisioning in the same node. But if it goes to here, it cannot access the data. Okay. So any doubts on host path and then empty directory?
Shiva, one small doubt. In case if this particular pod is for if it's a DB, then what kind of thing we'll do for storage? This particular host path only, right? In case of
No, no.
DB.
In case of DB, we don't go to this. We will go to external storage.
Okay, fine.
Okay. So you may lose your Kubernetes cluster also, but external storage is something different, right? There will be a separate storage area network, and dedicated people will be working on it.
Okay, yeah, we in general for big companies they'll have a separate DB team, so they will take care of the DB infrastructure.
Yeah. So DB team storage also will be there. Storage team also will be there. So they will take care of the data. Even your company, everything goes down, still you can recreate that using the data. Okay, so that is the host path. So empty directory host path where you can use is there is a concept called sidecar containers. Okay, for example, you have your pod and you have your application container running. There will be a sidecar container like this. What this will do is this is sidecar. This is main application container. So this application container will be writing lot of logs, right? But you need to analyze those logs. You cannot open the pod every time because it will not show you the full logs. You need to send these logs to the one external system called ELK. Okay, so in that case, this sidecar container will use something called empty directory volume, and then it will push the logs from here to here. Okay, when your pod is gone, you don't need of any logs, right? your sidecar is also gone. So in sidecar pattern, you use empty directory volumes because you don't need to push the logs when the pod is lost. Okay, you can use that empty directory or host path in a sidecar containers. We'll discuss anyhow. We will push the logs of our pods and containers to the ELK for developers access. And then second thing is external storage. So since we are running in AWS, we will create one EBS volume and we can attach to the pod. Now in that case, either you lose your pod or Kubernetes node, everything, still you have the data available. You can create another cluster and you can attach the same value to that pod. Okay, so that is the concept here. For that purpose, we have an example. You have this option available for any cloud like Google Cloud, Azure. Okay, since we are using EKS, we are going to provision our volume in EBS. You have option with Azure as well. Okay, so this is the example. Okay, test EBS, CentOS command sleep. Send test EBS. Now you need to create one EBS volume. Same like here. Your administrators will create one storage disk and they will give you the details. Then you can attach to your pod. So similarly, let me create one volume, just 2 GB, and make sure wherever your instance is there, then you should have that EBS volume. This is not a network. This is like a disk. Like your hard disk is in India and you are in US, you cannot connect, right? So similarly, wherever your Minikube server is there, in the same availability zone, you can create your volume. Okay, since our Minikube is in 1A, I'm creating here. Just create a volume. So you got your 2 GB hard disk created. Now I need to attach this to our pod. Just take the volume ID, give it here, and then that's it. Now the volume information is here. It is saying AWS Elastic Block Store, and you are attaching to this volume mounts. Okay. Now let us apply this. kubectl get pods. Now test EBS is running. You saw earlier the status was available. Now it should be in use since it is mounted to the pod. Okay, now let us go here, kubectl exec-it test EBS bash /test EBS echo hello.txt. Okay, now if I delete this pod, It's taking some time. It needs to release that as well, right? Okay, got deleted. Now you go and check here, it should come to available stage. But you have your data available, but it is not inside the node or inside the pod, right? Now you lose your Kubernetes your node or whatever, then you still have your volume. Tomorrow you can create another Minikube cluster, you can attach the same volume. Okay, now your data is safe in an external storage. This is like you create your volume and then you do it. Now there is one problem also here. Now I'm creating the volume manually and then attaching it to the pod. Since we are running in a very dynamic cloud environment, microservices, every time we cannot wait for someone to create the EBS volume to us. And this EBS volume, there is one limitation. So this approach, the limitations are volume should be created first, and then you cannot attach these volumes to multiple pods. So to solve this, we have something called EFS, Elastic File System, something like NFS. And here pod should be in the same region. Region and availability to both. Okay. So if your node is in somewhere in US and if you attach a pod EBS in India, that will not work. These are the limitations. Okay, we will solve these limitations one by one. First, volume should be created first. So what if my pod is running, I want 5 GB volume. What if that pod can dynamically create the volume and attach to itself? Then you no need to create a volume manually and attach to the pod, right? So that dynamic thing, whatever we discussed is now static provisioning. So in Kubernetes persistent volume concept, there is two things. One is static and the another one is dynamic. Whatever we saw just now is static provisioning. You create the volume first and you attach to the pod. Dynamic is your pod itself can create the volume in AWS and it can attach to itself. Okay, that is possible through the thing I already said now, like what is it? Storage class. Okay, storage class PVC and PV. PV is physical volume here actually. It is physical like some hard disk. PVC is claim. It's not physical, it is logical. You claim the volume available. And storage class is like a driver. Like keyboard driver, if you want to interact with your keyboard, you should install keyboard driver. If you want to interact with pen drive, you should install pen drive driver, like mouse drivers. So there will be drivers for everything, right? Similarly, your Kubernetes pod should create a volume dynamically. It should have storage class. Okay, for example, there will be EBS drivers, EFS driver, and Azure disk driver, whatever it is. Some third-party drivers are also there. If you install these drivers, it is just like a pod here, and there will be a driver, and through this you can create a volume. This driver will create the volume. Okay, so there will be different drivers for different things. This is EBS driver. This is Google driver. This is Azure driver. This is something else like third-party storage providers also there, not only cloud, like something SIF. Okay, so these are the drivers available. Then you can just this pod, if it has this EBS driver, it can create a volume in EBS. So these drivers we call it as here storage classes. Okay, now let us see what are the storage classes available here. kubectl get storage classes. Now we have this GP2 means it's a provisioning type in AWS. This is EBS. This is also EBS. This is also EBS. You can see here. If you have storage installed for Azure disk, if you have driver, then this minikube can create a driver in Azure also, like Google as well. So in tomorrow's class, we will see how to create the EBS volume automatically through the storage class PV and PVC. And then we have something to discuss like what is the retention policy. Okay, these things. Any doubts still here? We can stop today and tomorrow we can discuss the EBS dynamic provisioning. And later we can address the another limitations with EFS. Any doubts, Senthil, Ravi, Gopi?
Yes, we are clear. No problem.
Okay.
No, bro.
That's all for today then. Have a nice day. See you tomorrow. Tomorrow Saturday we can have the class still. Okay.
Okay, sure. Yeah.
Yeah. Bye.
Thank you,
See
sir.
you.
Yeah, thank you, Shiva.